Okay, this page is the page that I gave you last class period. At the bottom of this page, I've added 2 new problems compared to the page we filled out in class on Tuesday. Okay? So, if you did not print these new notes out, then you will want to write this down. Hopefully you printed out the whole set of notes and it'll be easier for you. So let's look at the bottom 2. So C3H8 plus O2 yields CO2 plus H2O. So tell me what to do. Try it. Let's try it. Make sure, looks like we got a mic, so let's hope it works. All right, so try this. Tell me what to do. What's the thought process? Tell me. Anybody?
You look at each of the elements.
So what do we say first? What am I going to start with first?
C.
C. So how many C's do we have on the left? 3. How many C's do we have on the right? 1. Do I use a pen to do this? No. Grab a pencil. So I'm going to put 3 here. That makes C3, C3. And then I've got 8 hydrogens on the left. How many do I have on the right? 2. So what do I need to put in front to make 8? A 4. So that makes 8 hydrogens on the right. So C3, C3, 8 hydrogens, 8 hydrogens. Now, obviously here I only have 2 oxygens. On this side I have, what's 3 times 2? 6. Plus 4 is 10. So what do I need to put in front? 5. So I'll put a 5 in front. Again, double check it. C3, 8 H's, 10 O's, 6 plus 4 is 10. All right, you do the next one. See if you can do the next one. And then I'm going to give you some hints for some that will be harder later. Try it, guys. So what are you doing? You have C3 here. What do you do on the right? What do you put? 3. So you're putting a 3 here. So that's C3, 3C. Okay? What do you have here? 8. What do you put here? 4. Is that just like what's above? What's the only difference in these 2 problems? An extra oxygen here. So this is not the same compound at all. This is actually propane. If you got a propane tank, if you got a gas grill, this is what propane is. That's propane. This is not propane. Okay? Now we have the problem of this oddball oxygen who's literally odd. And when I say that, it's literally, this side has 3. That's an odd number. This side is always at this point going to have an even number because of this 4 in front. So we know it has 10. There's no way to put a 5 here. You can't put a 4.5 here. You have to use a whole number. Ethan?
Could we multiply the first thing by 2?
That's exactly what we do. That's exactly what we do. When you have a situation that seems impossible to do, try multiplying everything you've written and assume to be 1, multiply it by 2. It's exactly what you do. So here we assumed what? 1. So what are we going to do? 2. Here, this is why you use a pencil. We're changing that 3 to what? 6. We're changing this 4 to 8. Now, that means 6 carbons, 6 carbons. 16 hydrogens, 16 hydrogens. Count the oxygens on your right because that's what you're having to match. 12 oxygens plus 8 is what? How many? 20. 12 plus 8 is 20. We have 2 here. So what is 20 subtracted by 2? Or subtract 2 from 20? 18. So that means we need this to be 18. What do I put? 9. Now, hopefully you realize when you get something that you really want to make a half, you can't make it a half, so you have to double everything. And that was great that he knew how to do that, okay? So let's write down some hints. Let's write down some hints that will help you on all of this, okay? So if you have a spare sheet of paper or the back of that, whatever, let's write down some hints so that you can look back on these. And I wanted you to write them because if I just wrote them, they wouldn't mean as much to you. So I'm having you write them instead of me just putting them in your notes. So hints for balancing. Number 1, never write coefficient 1. All right, number 2, use coefficients, which are big numbers, in front of symbols or formulas. Do not change subscripts of formulas. You cannot change subscripts of formulas. Number 3, if odd number of atoms and even number of atoms on other side, try multiplying all coefficients, including 1, by 2. If same polyatomic ion, and I should have written this one as number 3, if same polyatomic ion on both sides, leave as unit. Do not separate.
What do you mean by do not separate?
If it's NO3 on both sides, leave it as NO3. Don't separate it. If an atom is hard to balance, leave it until the end. In other words, if you find you're going back and forth and one of them just seems like, man, this is going to be awful, I can't do this, then stop, don't do it, go to a different one. Chances are it will work itself out. And we saw that, I believe we saw that yesterday, or Tuesday rather. I may be wrong, but I think we did. Pretty sure we had one like that Tuesday. All right, and the last thing is if coefficients, and I'm going to put if all coefficients are not in simplest whole number ratio, make them. Because all of your coefficients should be in their simplest whole number ratio. So hopefully these hints will help you as you're balancing, and you will be able to say, oh, she said if I get odd and even, then I can try multiplying everything by 2, and that may solve your problem. Or if you've got one that's hard, stop on it. Don't keep going, okay? Stop on it. All right, so now then, let's go to part 2. So part 2 is doing the long scenario. What do you have your computer for, just out of curiosity?
I'm uploading that video to YouTube because I can email it to you.
What YouTube though? You can't upload it to my YouTube.
I know, but I figured if you could just, if I could get you the link, you could download it from there.
Oh, it won't let you email it?
No,
Oh,
because
wow.
it's bigger in this sense.
Okay, okay,
Is
that'd
that
be,
okay, or should I
yeah,
just
that's
like-
fine, but do it after class.
Okay.
If you don't care, do it after class, okay? Because you're multitasking, you're not gonna get what we're doing. All right, so 2 things we're doing in this section. State the type of reaction, and then write the chemical reaction and balance it. So if you look back at our goals, this is the second goal. Write a balanced equation from a word equation, and it also is the third goal. Determine type of reaction. So let's determine type of reaction first. So the first one, barium plus lithium chloride yields barium chloride plus lithium. What type of reaction is this? Single displacement. Very good. So single displacement. All right, nickel 2 bromide plus potassium oxide yields nickel 2 oxide plus potassium bromide. Double displacement. Good job. The stars are for the last page of these notes, so just disregard it for right now. Mercurous chloride plus aluminum yields aluminum chloride plus mercury. Single displacement. Nitrogen plus oxygen yields dinitrogen pentoxide. Synthesis or combination, however you want to call it, is fine. Aluminum plus oxygen yields aluminum oxide. Synthesis or combination. Benzene, which is C6H6 plus oxygen, yields water plus carbon dioxide. Which combustion is it? Complete or incomplete? Complete. So this is complete combustion. All right, so got that part pretty easy. Now then, write formulas. The first thing you do is write the formulas. Write all of these formulas. We're not going to do every one of these. Why don't we do the first, let's do first 2 to start with. Write formulas for the first 2 to start with. This is practicing your nomenclature. Okay, so here's what you should be doing. You should be saying BA plus, and you went up here, plus 1, -1, plus 2, -1. So LiCl yields BaCl2 plus Li. Anybody get that? Okay. That should not be hard for you folks. If that's hard, you better learn your ions and you better learn nomenclature, because that should be the piece of cake. All of this, honestly, should not be hard on this section. Nickel 2 plus 2, -1 plus 1, -2 plus 2, -2 plus 1, -1. So NiBr2 plus K2O yields NiO plus KBr. Yes or no? Okay. All right, now we are going to balance. And both of these are super simple to balance. BA1, BA1. Li1, Li1. Cl1, Cl2. So what do I put in front of Li? Cl. 2. Now what do we have to put over here? 2. Question on that. All right, do the next one. Balance it. You just had one number to put. Where did you put it and what was it? 2 in front of KBr. Very good. Make sense? Okay. Go to the next one then. What is mercurous chloride? What's the charge of mercurous? Come on. Plus 2. Chloride. -1. Aluminum, it's an element here. It doesn't have a charge, but aluminum here has a +3. Chloride, -1. Mercury, again, no charge because it's this element by itself. So what's the formula for mercurous? Hg2. Good job. Hg2. And then how many chlorides do we need? 2. Now, do we reduce that? Not in this situation. Most ionic compounds are written as empirical formulas. In this case, we don't, because mercurous is Hg2. That's how mercurous spells its name. So you have to leave it as Hg2. Plus aluminum, Al, yields, what's the formula? Al, Cl, plus H what? G, just Hg. That's mercury, the element. All right, now balance it. And this is a good one to test your hint skills. Okay, what did you put in front of mercurous chloride? What? Tell me again. 3. 3. So that made 6. What did you put over here? 6. Why did you put the 3? Because you had a 2 here and a 3 here. Is the only way to make that balance is to make it a total of 6. So what do you put over here? 2, and that means you have to put a 2 there. So 6 mercury, 6 mercury, 6 chlorine, 6 chlorine, 2 aluminum, 2 aluminum. Yes or no? All right, nitrogen plus oxygen yields dinitrogen pentoxide. No charges, why not? It's all what? What is this entire thing? What kind of compound? Well, what kind of compound are we making? Molecular. Everything involved is a what kind of element? Non-metal. Now, yes, you're correct. Nitrogen, how do we write it? Somebody said it over here. N2. Why do we write N2? It's diatomic. N2 plus O2 yields N2O5. Balance it. All right, when you balance this one, you're probably saying, okay, my N's balance, but my oxygens don't. What is the only thing you can do to make those balance? Make it a total of, so what do you put here? And what do you put here? And then you have to put a 2 here, okay? I'm going to leave these two problems, and this one is a pretty good problem to do. I'm going to leave these two problems for you to do later, okay? We may have time, but right now I want to move on to things that are harder. So let's slide to the bottom of the page. Now we have state the type of reaction, predict products, and write balanced equation. So we have a lot to do here. First thing I would encourage you to do is determine the type of reaction. That will make it easiest. Look at your front page. What type of reaction is fluorine plus lithium iodide? Single displacement. So that is a single displacement. So that one is a single displacement. Go through all of these and see if you can figure out what they are. Okay, calcium bromide plus potassium oxide. Double displacement. Chromic chloride plus cadmium. Single displacement. Lithium plus sulfur. Say it again. Synthesis or combination, whichever is fine. C2H6O plus oxygen yields combustion. Now you don't know if it's a complete or incomplete, but I will tell you this. If I ever give you one, you make it a complete. Make it complete. We don't want incomplete combustion. Okay? Complete is what our goal. So this is complete combustion. And if you, whoops, can't spell complete. And if you wrote it as just combustion, I would count it as that as long as you made it produce CO2. Now, if you made it right, if you did CO as your product instead of CO2 and you wrote combustion, then I would probably not give you full credit because it's really incomplete combustion if you make it the product of CO. Okay? So CO2 is the complete. Let's start with this one first. This one's the easiest one. What are our products? CO2, so we can write the words or the formulas, either one. I like putting the words here so then I can write formulas. So carbon dioxide and water. Let's keep putting the words. I strongly encourage you to do the way I'm doing and put the words first. Lithium plus sulfur yields. Think of these as ions. What are they going to make? What's the name of a compound made with lithium ions and sulfur ions? Lithium sulfide. Lithium sulfide. Chromic chloride plus cadmium will yield what? Cadmium chloride plus chromium. Calcium bromide plus potassium oxide will yield what? It already is potassium oxide. What's it going to produce? Potassium bromide. You said calcium oxide, didn't you? My apologies, I couldn't hear you. Calcium oxide plus what? Potassium bromide. Fluorine plus lithium iodide yields lithium fluoride. Very good. Lithium fluoride plus what? Iodine. I'm pleased to note that whoever's answering me did not say fluorine iodide. Why won't that happen? Positives replace positives. Negatives replace negatives. Cations replace cations. Anions replace anions. Now, do I have any of you who are realizing the need to learn your ions? Are you realizing the need to understand nomenclature. If you don't know it, and I pretty much am sure 90% of you don't because you're not answering the questions, 10% of you do, you need to watch the videos again. You need to study your ions. This is your test. This is your next exam. This is your next quiz, which is on Tuesday. This is part of it, okay? Let's do a couple of these. Fluorine. How do I write it? Come on, talk loudly so I can hear you. F2 plus Li is lithium. I plus 1, negative 1. What's lithium's charge again? Folks, grab a periodic table. Come on, what are we doing? Why are we just sitting here? This is very frustrating from my standpoint. I got somebody up here, got her periodic table out. That's what you should be doing. You guys don't have these memorized. Use your resources, please. Get your periodic tables out right now. This is chemistry class. Be where you are. Okay? Get your periodic table out. What are these charges? What is lithium's charge? Plus 1. What is fluoride's charge? Negative 1. So F2 plus Li yields, guys, I've written them right there. Come on, balance it. LiF plus I2. Do you need to make a note somewhere? Hofbrinkel? What did that mean? H2O2, F2, Br2, I2, N2, Cl2. If you don't remember those, make a note. Make a note on your paper. Hey, don't forget diatomic molecules. Make a note to do that, okay? Balance. 2 F's. 1 F. What do I need to put in front of LiF? 2. That made 2 Li's. What do I have to do here? 2. And that made 2 I's, and that balanced it. You do the next one. I want you to put charges above all those symbols, and you do the next one. Okay, calcium's charge, plus 2. Bromide, potassium, oxide, calcium, oxide, potassium, bromide. Thank you. That's so much better. Calcium bromide's formula. Plus yields plus KBr. All right, so now let's balance it. 1 Ca, 1 Ca. 2 Brs, what do I put over here? And that did it. 2 Ks, 2 Ks, 1 O, 1 O. All right. Let's skip this next one. You can do that one on your own. Let's go to lithium plus sulfur. Both of those are written as how? Lithium and sulfur. Li plus S yields, what are the charges? Plus 1 and, so what's it going to be? And so then what do you do to balance? 2 in front of Li. All right, do the last one on this page. You simply rewrite C2H6O plus O2 yields plus, okay? So when you do this, you probably start off as so. 2 carbons, put a 2 over here. 6 hydrogens, I'm going to put a 3 there. But hopefully at this point you're like, I might have some trouble, but don't freak, just look. So C2, C2, H6, H6, 1 O here, You have a 3 O's here. So 3 plus 4 is what? 7. This 1 has to count, but that will be what makes it odd. What do you put in front of this to make a total of 7? 3. So this one you didn't need to do any doubling. What happens if you did double and you came back and everything could be reduced? You reduce it. Does that one make sense? Okay. All right, got a whole nother page of these. You take some time right now to determine what these are. Determine the type and write down the type, and then go ahead and start writing out the products. Determine the type and write out the products. Let me give you a comment for that very first one. The reason I wrote it as HOH is so that you would see it's a single displacement, and that hopefully it was a trigger for you. Barium replaces who? Hydrogen. Okay. Now, on this one, you really don't know which iron to make it because that's something you don't know, and that's okay. If you make it iron 3 sulfate, then you make it balanced correctly. If you make it iron 2, then you make it balanced correctly. Pick whichever one you want to make it. I will make it iron 2 just to make it easier because that's what cobalt was. All right, do you have those? Does everybody get those products? Yes, no? Okay. All right. Let's look at the first one. Barium would be what? Come on. Ba plus, I told you to write water as HOH, yields. Do I need to give you time to write charges? Go ahead and write charges. For the rest of this semester, please print the notes. Those of you that want to write everything down, please print the notes. The reason I have taken the time to do this is because it saves you time. If you want to rewrite your notes, then you're more than welcome to do that. But please do that on your time, because on these solubility rules today, I'm going to give you the solubility rules on a test or quiz. That's something you don't need to have to write down in class when I give it to you. So please start copying the notes when I give them to you, please. So put the charges. And I know I'm to blame for making things late on you, getting the notes to you, but set 9 is already available, so definitely that one you should print out and have the rest of these printed out for next Tuesday. All right, so what do you have? BA plus HOH yields what? BA, 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 parentheses. Do you realize that? Why do we put a parentheses? Why do you have to put parentheses? Follow what I'm doing? BA parentheses OH parentheses 2. Nomenclature, folks. What's barium's charge? +2. What is hydroxide's charge? -1. How many hydroxides do you need? 2. You must use parentheses. Guys, you all need to watch your nomenclature videos again and practice nomenclature. Last one, H2 or just H? H2. All right. Let's go through and write these down, some of these, and then we'll come back and balance. I don't think balancing is our issue. I think the issue is nomenclature. Strontium, how do I write it? SR. Zinc nitrite, how do I write that? Come on, say it. Parentheses, ZN parentheses, NO2 parentheses 2. Yes or no? Yields. SR parentheses NO2 parentheses 2 plus ZN. Guys, is that one balanced? Yes. That one is balanced. You okay? That one's balanced. We better go back and balance this one because we don't, you're going to wonder and think it is. So let's do this one. 1BA, 1BA, 1H, what do we put in front? 2. Does that make 2 OHs and that makes those 2 OHs? So that one's balanced. And you make a note to yourself, this one is balanced. I'm going to be quiet and let you write formulas for these. 2 of these are super easy. The formulas are basically there. It's these 2. In fact, let's just do that. Write the formulas for these 2. Right now, write the formulas for those 2. I've already put charges. So write the formula for those 2. Okay, what do you get the formula for cobalt 2 sulfate? COSO4. No parentheses at all. Why not? You only need one SO4. You only use parentheses if you have more than one. So it's COSO4 plus Fe yields FeSO4 plus CO. Guess what? It's balanced. That's one of the reasons I made it make iron 2 sulfate and not iron 3. It would not have been balanced had it been iron 3. Okay? All right, sodium phosphate. What's the formula? Na3PO4. Good job. Plus parentheses 3. Good. NaNO2 plus PO4. Okay. So what do we do to balance it? Very good. And that's all you had to do. Because of the phosphate and the aluminum both being a 3 positive or 3 negative, that's what worked. Okay, let's go back. I see the need to do this. You've got these two to do. These two, because you've done enough of these and you know the formula for oxygen, O2, CO2, and water, both of those are balancing issues. I'm going to let you balance those. You need to learn to balance those. That's something I know you can do. These two, though, these three rather, I'm back to the problem of, do you know nomenclature? So actually it's 2 of these. This is again a balancing issue. Write the formulas for these 2 problems. You write the formulas for those 2 problems. Okay, aluminum, what do I write? Al plus yields. Good job. What do I do to balance it? 2 in front of Al. Is that right? That's what you start with. You're correct. That's why I'm using a pencil. That's what you're going to start with. Then what happens? You get this odd-even scenario. So what do we need to make oxygen have a total of what number of atoms?
6.
So what do we put in front of oxygen? What do we put in front of Al2O3?
2.
Which means I have to erase this 2 and make it a
4.
good. All right, you come back and do the benzene one. Now come down here. Chromic is what charge? Chromic. Plus 3. Chloride. Cadmium, we aren't with the charge, but here we are. What's the charge of cadmium? Plus 2. Chloride. All right, so the formula for chromic chloride. Cr, Cl3 plus C D yields CdCl2 plus Cr. Balance it. What do you put in front of CrCl3? 2. That makes 2 CRs. What do you have to put over here? What do you put for that is 6 chlorine. So what do you put here?
3.
And what do you put here?
3.
Okay. All right, so that leaves you 3 to do that we have not done, and every one of those are basically the same. Okay? Now, I am not comfortable with starting net ionic equations right now because I don't think you know your ions. And it's kind of pointless to do that if you don't know nomenclature in your ions. So, I'm going to talk about our quiz that's going to be on Tuesday. This will put us just a tad bit behind, which means on Tuesday before the quiz, we are going to be doing all of this information on net ionic equations and hopefully starting on stoichiometry. So I would encourage you to read over these. You do not have to memorize the solubility rules. You do have to know how to use them, okay? Just so that you know, in case you're looking back at this later and want to kind of get ahead, these two that are the 3-star and the 2-star, those are these equations from the previous pages. So if you want to go ahead and write this down here, your balanced equation on those 2 spots, that would save us time on Tuesday. Okay, does that make sense? Because you have those now. And so you could write those in, and then we're going to write the net ionic equation from those. And you will also want to leave a little bit of space after each of your formulas because we're going to put in the state. That's, if you notice, this is a little different than what we have been doing. Do you see how the states are on all of these? And that's why, because we have to know that in order to do net ionic. Okay? So that will be Tuesday along with your quiz. Thursday we will be doing, basically we need to do, and I think it's possible if everybody brings their notes with them, it will be possible to do all of this on Thursday. And then your test is going to be on the 7th. Okay? So let's talk a little bit about your quiz. It's going to be held in 3110, Snell Hall 3110, so that means you need to be in 3110 on on Tuesday next week. And your quiz is going to cover mole, gram, atom, molecule, formula units, empirical formula, molecular formula, and percent composition. And I probably will put 1 balancing equation problem on there, maybe 2. Here's the problem, if you think about all that. That's a lot of information. That's a whole lot of information. So let me just explain to you, not everything will be on there, okay? Let me give you an idea of what I mean. An empirical formula problem and a molecular formula problem can be the same problem. Because in order to get a molecular formula, can I make you get the empirical formula first? Okay. So that would be like one problem. And then a percent composition problem, instead of having you determine the percent composition of, say, 3 different things, I'd be only making you determine the percent composition of 1, because that would save you a lot of time. I'm not going to give you 5 problems on gram, mole, atom, molecule, formula, unit. There might be 1 problem that converts grams to atoms, because doesn't that incorporate grams to moles, moles to atoms? Yes? Okay? So I don't need you spending an hour on a quiz. I won't give you an hour for the quiz. That's the problem with having in-class quizzes, because it takes so long. You will have a quiz. I will take the quiz. If I can take it in 10 minutes, I'll give you 25 minutes. Okay? That's how it's going to be. And it's going to be timed at the end. I won't say timed, but you will have a time limit. And it will be held at the end of class. Okay? So you need to bring a calculator. There might be a balancing equation problem. I will probably make everything multiple choice just to make it faster to grade on my behalf. But again, your work will have to be shown. So you can't just come up with an answer or you will not get full credit. Okay? And that goes true too if your work is correct, your answer is off because of significant figures or something, or maybe it's just one little mistake, then I would give partial credit as long as most of your work is correct. Okay? So make it logical on the work. Okay? Questions on that? Any questions on that? Okay. I will see you. I'm going to let you go now. I hope you'll spend your time working on nomenclature and ions, okay? And I will upload this. Oh, wait a minute. I do want to show you. Sit back down. I need to show you this because I figured this out and I think this is good for you guys to know this because many of you are freshmen. So I'm gonna show you, I figured out